talk about compositing, there are so why might you want to composite images in the data cube? Main reason, clouds. Uh, clouds kind of plague all sorts of remote sensing data collection at any one time. Clouds could be covering up to 60% of the Earth. That's kind of like an average. And so clouds appear in many of our images, and they end up obstructing and corrupting our data. So dealing with clouds and data corruption or ill-formatted data becomes a very difficult problem. A couple of other reasons you might want to use composites where you combine multiple images into a single one. So the first one is to create a more complete data. So here we have clouds that have been masked out of this image. And we might want to fill this in to kind of make a more cohesive image or overview of the data. Another reason might be to take a large amount of data and kind of compress it into a smaller amount. So that way, if we had like a very long time series, we could make composites of certain periods of time in order to make that time series more manageable and actually view the change kind of more continuously over the whole, instead of trying to choose individual pieces from that long time series. And a third reason we might want to do this is to try to create a more representative but synthetic image. So one example that's maybe a little bit more complex would be that, let's say we have images, satellite images from multiple years, right? But I want to look at what like a representative image of the month of January looks like. I could composite all of the Januaries from multiple years together to create a representative January image. So those are just a couple of the reasons we might want to create composites. It may not be like through time. It may be after like a specific event or something like that. Maybe you want to look at a lot of different images after the rain and like before the rain and maybe make some sort of comparison, but any singular event may not be representative of the kind of change you're looking for. So you can make your analyses more robust, is I think the general point here, by creating composites from satellite data. So how to combine the data? I think the simplest and most straightforward approach is using arithmetic averages. These are the simple statistics we're all familiar with. So one tool that people often immediately reach for is using the mean. And this is implemented in Xarray. Like you can use it as a function in Xarrays. And I know we're trialing doing subtitles in French today. So I know it doesn't actually pick up on Xarray that well, but hopefully it's helping get across a little bit of more of my meaning. The mean is simple to understand and to calculate, and it is also easily available in combining data sets in the Xarray. But the mean has a couple of problems, which is that, as you can see from this picture, is that if I have any sort of skew to my data, the mean may not be very representative at all of my data. It really works best when you have kind of like a Gaussian distribution. And as we know, especially when you're looking at trends over time, these things can be cyclic or they can be kind of linear, or you're looking for kind of a change, right? And so, especially when you're talking about combining over time where there could be significant change, this could be a problem. The other reason that it's a problem is that we want to potentially kind of repair. I'm putting that in quotations because that's not really what we're doing, but we're trying to fill in potentially data that's been masked for clouds, and the mean means there might be some wisps of clouds, some small parts of clouds that have crept into our data. And so the mean can be very vulnerable to either some sort of contamination or corruption or outlier as well. So the mean, even though if done over long enough time period, will produce good results, if attempted over short periods, oftentimes in my experience, it does not produce results that are that great. So perhaps we want to reach for another easy statistic, the median. So medians are nice because they kind of make up, they perform better than the mean in many respects when it comes to corruption, contamination, and the skew. As we can see from this one, the median here in green is still more representative than the mean. It's not as affected by outliers. In fact, you can have up to 50% of your data points being corrupted until you can't actually get an accurate median. This is very enticing for us to try to create composites out of this. And so the way you would go about this, I realize here, looking at the slide, I have a typo. It says geometric median. We're about to talk about geometric medians. That should say a median composite. So on the left here is, I want you to visualize, this is kind of like the data we have in the data cube, right? We have, think of that as like 4 different pixels. So let's say we have a 4-pixel image, right? And we have a time series of these. So we have our latitude, our longitude, and our time, right? And we want to try to make a composite out of these images, right? So the way we would calculate the median for this image is that for each pixel, we'd look at the time series data, right? And in fact, for each pixel, right, we don't have a single value. We actually have multiple values. We have usually maybe a red band, a green band, maybe IR, shortwave infrared, something like that. And for each of the bands in that pixel, right, so breaking that out, we see our red, green, blue. We would then calculate the median for just the red channel of that pixel. And then we'd calculate the median for just the blue channel of that pixel and the median just for that green channel of that pixel, right? And then we would then come up, that would then allow us to create a median pixel, right? It would be, the RGB values would be the median of each of their representative channels. And therefore, then we have our median pixel, and then we can place it in our composite. Hopefully that makes sense. If anybody has questions, feel free to comment during the presentation, even interrupt me. I'm happy to provide additional explanation. Was somebody asking a question?
Yes, there's a hand from Kyria.
Okay.
Yeah, sorry.
No problem. I'm happy to answer questions. So, did you have a question?
I think that she has a problem with the mic.
Oh, okay. That's fine. So, hopefully I've kind of made it clear how to calculate how a median composite is calculated. Oh, are you able to speak now?
Yeah, Brian.
Go ahead.
Hello? Yeah, so can you help me please on the explanation? Yeah, on the explanation when you say compositing is used to combine large amounts of data to make it small.
Right. So going back here, like one of the reasons why you would want to create a composite is, let's say, so the idea being that if I had a very long time series, the question becomes, how do I then sample the time series without maybe having to display every single picture in the time series, right? How can I kind of represent the time series without having to display all that data. So by making a composite of periods, small subsections of this time series, I'm actually making the amount of data I have to process much, much smaller, because I could combine like a whole month of satellite captures into a single capture, right? And so then if I had multiple years, then I would only have 12 captures for every month. Let's say you had multiple years, you could have an annual composite, and then if you had 40 years, that would leave you with 40 composites instead of potentially thousands of captures that you would have for like a 40-year period, especially when you're looking at the Landsat archive, which is very, very long.
Yeah, thanks, Ian.
That answers that? Okay. And so
Yeah,
when
yeah,
I'm describing, good. So when I'm describing this this process here, this is the process by which we would be combining multiple images to try to create a single image out of multiple images. So on the left here, the idea is that we have like this like little representative 4-pixel image, and there's a time series of them all stacked up, right? And I would actually look at the values of a single one of those pixels for each one of the channels, take the median, and then create a median pixel out of that. And that's how I would generate my single image. So I say here, however, this might not be the best choice for higher dimensional data. And when we have multispectral data from a satellite, this is high dimensional data. We're not dealing with just one channel. The problem here is that we have these 3 channels, red, green, blue, or perhaps shortwave, infrared, red, and near infrared, or something like that, right? We have multiples that we're usually manipulating as part of our analysis. So what is a better choice for this? And there are these idea of these higher dimensional medians, but I shouldn't say, this was supposed to say applying advanced statistics. I forgot to correct this. But this is there's not an agreed upon way to calculate a median in higher dimensions. So we can actually think of each one of these pixels potentially as a point in 3-dimensional space, where one axis is red, one axis is green, and one axis is blue, right? And that pixel has a value for each one of those, and so therefore it kind of lives in a 3-dimensional space. And for a single image, right, I can actually put all these pixels in this 3-dimensional space, or for a single pixel here. So I'm actually going through a similar process from the previous one. And here we have our example 4-pixel image. We're taking 1 pixel and its time series, and then I'm kind of projecting it into the red, green, and blue 3-dimensional space, right? And the idea is that for all those values that pixel through time, it now there's like a scatter of them in 3 dimensions. And what would be really nice is it could create a point in the middle of this scatter, right? That was kind of the average of all of them. That was kind of at the center. And I could then use those values to represent that pixel. And that's what the geometric median does, right? It says is that we calculate a point that minimizes the distance between all other points. So it's kind of like the center of gravity of, if everything's weighted equal, it's kind of like the center of gravity of all these pixels. And then it uses those values to do that. Now, why do I want to do this? Why do I want to go through all this complexity and trouble to figure out this kind of like center point of this like higher dimensional thing? Well, the problem with our previous method was that we were considering each channel independently. And that's kind of all right if we only want to look at a single channel at a time. But many times during our analyses, we're actually comparing these channels together. And what I really want to do is I want to preserve the relationship between the bands. And it's important that I preserve this relationship because, when I take the NDVI, or I'm looking at the water index, or one of these other indices that I'm doing, right? It creates almost a more representative pixel instead of having one of the bands, right? Like that the blue value could be very, very off compared to the change in the other values, for instance. So here is an actual scatter plot. So this is taken from a paper by Dale Roberts, who a lot of this work is based on. And on the left here, we have the geometric median. And then on the right-hand side, right, for each one of these, on the right-hand side is a clear capture of that area. And I want you to notice the distribution of the data here, that the geometric median better follows and has a more dense cluster of that. Now, keep in mind, the geometric median is going to be a combination of multiple images, so it's not going to be the exact same shape, but it is more closely following a clear capture. And we can see so the top is blue versus red for I believe for kind of a capture over water, and the bottom is I think over land, and it's for SWIR versus red. And you can see they all have kind of different shapes, but notice how tightly grouped the geometric median is and how that really reflects the distribution of the clear distribution of pixels. So it creates it does a better job of preserving the relationship between the bands, which is especially important when we are looking at the relationship between bands to calculate indices. So another tool in our toolbox that's one of these other higher dimensional medians is called the Meteoroid or the Meteoroid. And the Meteoroid is very, very similar to the geometric median, except it requires you to choose an actual point, right? So it says of this three-dimensional, keep in mind we have this kind of like three-dimensional scatter of the pixels, right? Of that time series of pixels. And instead of creating an imaginary point at this whatever I define to be the center, and that's actually where the debate amongst like mathematicians, or that's why there's not a single way to define this, is that there's many different ways to calculate the distance to the other points. But let's just say we're choosing a center, a definition of what the center is. With the Geomedian, we create a point at the center. What the Meteoroid, asks you to do is it actually chooses a representative data point that is closest to that imaginary center. So it is an advantage here is that we are choosing a pixel out of the data set that is closest to the center. And this is nice because that means that this pixel was actually those values at some point in time in our time series. So from like a idea of doing analysis on real data, that is very nice. But one of the disadvantages is that depending on how each one of our pixels changes through time, it could be choosing pixels from very different points in time. So I could be getting like a summer pixel here because it landed very, very close because it actually didn't change all that much through the year. Or I could be getting like a spring pixel from the other one. And so when we look at this actual kind of visual comparison, it almost looks like the Meteoroid is more pixelated. And that's because each one of these pixels will potentially have a unique time varying signature. And so what pixel is the closest could be kind of subject to either some randomness or some uniqueness from how that pixel varies through time. And I want to kind of also point out how smooth and how close the Geomedian looks to the real capture on the right. I think that's one of the real advantages of the geometric median, and it also it appeals to our senses of vision, right? Is that it looks good. I think that's another reason why people really lean on it, even though the Meteoroid is actually valid. But as you can see here, the Meteoroid can do kind of weird things as well. Like when we look at that top part, we're actually kind of getting a bimodal distribution. Perhaps because of seasonal. I really don't know why that is happening. It probably merits further investigation. So, okay. You may be asking, this is all good and nice. I don't really know how to calculate all this, but it seems like I want to take advantage of this. And you can do that on the Sandbox. So there are 2 notebooks that are available right now on the Sandbox in the frequently used code folder. One is the generating composites one, which will walk you through generating composites based on the simple arithmetic, mean and median. And then there's the generating Geomedian composites, which focuses just on how to generate Geomedian composite images. And that uses the, if you're trying to access this yourself, there's a couple of ways to do it, but I think a really convenient way is you can import XR Geomedian from odc.algo. And we can talk about, if people have implementation questions, I'm happy to answer those. There's also, which is like even simpler if you don't want to do any of that, there are also, they're adding actually pre-computed Geomedian products to the Sandbox, to the data cube, for you to access and use immediately. And so that makes it even simpler. There's no calculation to be necessary, because one of the downsides to the Geomedian and these higher dimensional statistics is they can take longer to calculate, and this can take up quite a bit of memory. If you're struggling with using too much memory in our notebooks, which oftentimes, I've done that a lot. It happens quite often when you're trying to analyze very large areas. So, let's say you're really thrilled about this idea and you really want to know more. I'll actually change these to links to the GitHub page. I realize I neglected to do that. There's the HD stats and HD medians. They're both libraries from Dale Roberts, who actually wrote this paper. And then I'll include a link to his 2017 paper, High Dimensional Pixel Composites from Earth and Observation Time Series. That's where these figures at the end actually come from. And it really gives a nice breakdown of kind of like why one would do this during an analysis, although it is a dense paper. All right. I guess, do we have any questions? I kind of wanted to show the notebooks on the, just to kind of make sure everybody knows where they're at on the Sandbox real quick before I conclude. But if anybody would like to type a question or ask a question, I'd be happy to answer it.
Thank you very much, Brian. The presentation was so great, just that we took some time, but it was really well prepared. Will you be able to share the PDF with us on this?
Yes. So when you log into your Sandbox, there's these folders. Go to frequently used code, and then there's this generating, hopefully I'll blow this up here a little bit. There's this generating composites notebook and the generating Geomedians one, and it actually has a lot of code here, really explains it all. Walking through this, I think one of the things that's kind of harder to get around, but is how to group your X-array on your time series. And there's multiple different ways to do this. So it's really nice to have the examples here. And it's great to be able to refer back to this. And then finally, if you're trying to find a product on the Sandbox, going to explore.digitalearth.africa, you can look at the different products. And there are a couple of products here listed, such as the Landsat 8 annual Geomedians. And we can see the extent here that has very, very widespread extent. Yeah, and then take a look at this paper by Dale Roberts. Thank you.
Thank you very much, Brian. There was a question in the chat for you from Kelly.
I see. Is Geomedian similar to PCA? Not really. I mean, PCA, the similarity comes from that they're treating the pixels as like these kind of like higher dimensional objects, right? And whereas principal component analysis, you're trying to find some unique vectors to explain the variation in the pixels, right? And then kind of find the and like so one, you're kind of more dealing with the actual like basis vectors, right? And trying to move your data into kind of those values, whereas geometric median is very much concerned with just trying to find representative pixels or creating representative pixels of lots of data. So they are like kind of related in that sense, but not in a like mathematical like the actual algorithm to do so is not that close. Yeah. Hopefully that answered it. Or if there was a more in-depth one, we can get into it. But yeah.
I think that's a good explanation. And also in your notebooks, there was 2 separate notebooks on the same. So there's one for Geomedian, there's one for PCA. And we'll be able to explore that further with you. So mine is to thank you very much, Brian, for your great presentation. We need to have some extra time for one of our colleagues, Eric Mwala. He would like to present. Eric Mwala, you have the screen, sir.
Okay, thank you. Let me share the screen. Okay, I want to talk briefly on Lake Bosomtwi. This is a lake, and I just want to show you some few pictures about it before showing you the sandbox. This is one of the natural lakes in Ghana here. It has various activities which are undertaken here, and is located in Ashanti region. This lake is very protected because it's a natural lake, so there have been various programs to ensure that its biodiversity and also the water itself is protected. So as a result of that, it is even part of the UNESCO biodiversity protected areas. So I wanted to look at what has been the effect in terms of maybe if there are activities close to it, and what has been the effect on the resource in terms of the volume. So I ran the sandbox and to look at the water extent of the Bosomtwi itself. So if you see here, this is a Bosomtwi, and I had a chance of getting some shofars from Buama to lay on the lake itself exactly. So in running the sandbox, I was looking at the area. So I want to show you some of the results. Looking at the results, you can see here the various years and some of the outcomes. The red areas seems to be some dry areas, but they don't seem to be much. So these are some of the plots of the respective years with respect to the lake. If you go down further, we look at here shows the projection or the series of the area. If you look at the web, it says the surface area of the lake itself is 49 cubic kilometer cube. If you look at our sandbox, we could see that several of them are very, what we have here is 48. We could see that several of them are very quite close to the 48, and there says to be some slight changes. So these are some of the variations when it comes to the years. Now we can see here an outlier. So in running the sandbox, we saw that this outlier was as a result of how do I call it? Several clouds, which we found over here. And also, there was also a comparison. If you see here, the year 2019 July and 2017 July, those were the years with the maximum and the minimum. So going back to the graph, we could see that the year that we are referring here, which has much clouds, which is this one, is what we are seeing over there. So it means that it wasn't actually the lowest, but because of the cloud issues that we have over there, that's the reason why we have that year has been minimum. Then if you go further, we run the image. So as you can see here is the image for several years and the way it looked. And we have to compare, we compared 2 periods of the same year. So what we have here is 2017 December. This one is 2020 December. If you compare, you can see that, I mean, there wasn't any much changes. There wasn't any much change. So in general, if you plot it and look at the graph here, water to water, most of the time it was 75%. Then water to no water, I mean, very minimum. But in terms of if you calculate it in terms of the area, I think it should be around 1,004 meter cube. So in summary, I mean, this is what I run using the Sandbox to determine the water extent of the Lake Bosom Chain. Thank you very much.
Thank you very much, Eric Mwala. And I think from these, we can have some reaction from the colleagues and also a great work again.
With the help of Buama.
Absolutely. This is Lake Busumtui.
Yeah, Lake Busumtui.
Okay. Edward, would you like to add something on this research?
Okay, thank you, Ken. So one of the things that we took notice of while doing this use case was the data that was used here was Sentinel product. I think Eric has made mention of that, and we just wanted to find the effect of that water body over the period using the Sentinel data. And just as the result that shows here, meaning that although the lake has been there have been some minimal disturbances around the surface of the lake, which actually needs investigation. So using the Sentinel product, you're able to actually know the areas that has been affected. And I think Eric and his team will take up upon that and also go and investigate why around those shores, maybe there's a reduction in the water bodies. So it was actually a really great project for one particular lake here in Ghana. That's the natural lake here in Ghana. That's Lake Bosomtwe. And we hope that using this notebook, others can also pick it up and run it on various water bodies within their countries to see how the Sentinel data will be able to generate these results. Thank you, Ken.
Thank you very much, Edward. Will this notebook you be able to share with the others? I know David will be very keen to try it somewhere and other partners.
Oh, no problem. I think very soon we will make it available in the Sandbox whereby everybody will have access to it. So
thank you very much.
Yes. Okay. Yeah, so I think there was one use case that we were working together with Brian and August. That's from the AMA team on the grazing. So for the grazing notebook, it actually combines two different products. That's the water extent and the vegetation phenology. It's actually a really, really interesting use case. And that's one of the results. That's the notebook water extent is what Eric used to monitor the Bosomtwe. So hopefully, once that notebook is made available publicly, everybody will have access to it to also run it on at their own end. And A new folder will be created called use cases folder. So that one, once you go there, you will see the use case for those ones, then you pick it up and modify it to use it at your end.
Thank you very much, Edward. Also from the participants in this call, will you have any questions for this team, Edward, Eric, and Brian?
Yes, I have a question.
Yes, please.
Thank you very much, Brian, Eric, and Edward, for your presentation. My question is to Brian. So in what situation will you choose to use median over geomedians? Or do you always use geomedians?
That's a great question. There's a variety of situations where even like the mean might be appropriate to calculate. I'm trying to come up with an example on the fly. The one reason is actually computational time. I think that would be a big one, right? Is that the geomedian can take a while to calculate, especially when you have a very large data set. Imagine, if you will, it has to. You basically, depending on the number of bands you have, especially if you had, let's say you loaded up all the Landsat data for multiple years, right? And then you look at the time series data for that single and then imagine the time series data for that single pixel. Well, it's not just going to be that single pixel times 100, right? Now you're going to have to, in your calculations, it's that pixel times whatever 8 bands are there, right? Like you have the red, green, blue, SWIR, near, right? And in order to calculate that calculation actually becomes quite big. And taking the mean can, or median even, can be quite quick, substantially quicker, because all you're considering is like one band at a time, and it can be more easily computed in parallel by the machine. Another, I think that would be a big reason. Another one would be is if you're using a single band. There's no reason really to use a geomedian if you're just looking at the red band, right? Like if you're considering bands by themselves, right? If and the other thing is that if I'm also just creating things for visual representation, sometimes the median can be adequate, and particularly the mean over long periods of time. So I'm talking, like if you have lots and lots of captures, will actually generate something quite close to the geomedian, because the idea is that there's enough outliers that you have enough regular points that the outliers don't have as much of effect. That's not always true though. And I will also say that the quality of like a visual image that the median will create can also look a little bit splotchy. I think we actually kind of saw that showing up in that previous notebook when we saw that animation going back. It was probably for calculation purposes. Keep in mind, we're only trying to identify the water area. So like the visual representation of that does not matter that much, right? And so in order to identify the water, that's actually a great example, is that the regular median is just fine, right? Because MNDWI is quite robust, and I'm actually just wanting I just want to create a time series of kind of the images, but I want the splotches filled in with like some data. I don't really care how it's visually represented. But for RGB data, and I'm trying to make a really nice looking picture, Geomedian may be your best bet. I know that was a really long-winded answer because it's not clear cut. I will say that.
Okay.
I would say 10 towards Geomedian. Yeah. I'd say 10 towards Geomedian, but the median can be fine in some circumstances.
Okay. Thank you very much.
Yeah, no problem.
Any question for any of the presenters from the audience?
I have the floor.
Hello.
Yes, Ahmad. Yes, Ahmad.
Yeah, thank you very much, Brian, and also presenter. Are you hear me?
Yes,
Yes.
and also we can see a very good view from the Dakar.
Okay, thank you. I have the sea behind me. Okay, thank you. Just a question for Brian. If I want to use the geometric median for biophysical detection change
Yes.
across the multi-annual periods, what precautions I have to take in order to conduct this kind of a study? Is there are you some articles addressing this, demonstrating this this topic using geometric median for geophysical detection change? Thank you.
So the advantage of the geometric median in some way is that it allows you to deal with data that may be kind of affected in some way. You asked specifically about across multiple years, I believe.
Sorry, can you?
Across many years, or
yeah, many years, yeah, multi-annual.
Okay,
period. Yeah, many years, yeah.
right. So I think one thing when doing something across many years is that there's a couple of things you can do with regards to having a rolling period in which you create your medians from. If you wanted to see something across multiple years, you could get a more, if you're more interested about like kind of a seasonal change in any given year, you can actually kind of stack multiple years and then combine them in order to get kind of a representative year, if that makes sense. But going back to what I was originally saying is that one of the advantages of the Geomedian is that if your data is tainted in some way, by combining captures from that are very close in time, you can help cancel out, for instance, let's say the cloud mask missed a small amount of wispy cloud, or let's say there was some smoke or additional haze that was in only a part of your image. By compositing multiple images together, I can make my analysis more robust to these kind of transient disturbances. With regards to the paper, I would actually start with the Dale Roberts paper to kind of understand what the point is of a geomedian. If you're looking for something that only occurs in a single capture, right, that it has a very small time span, the compositing will destroy that, right? Like if I'm looking for instance, a flood, right? Something that would only be there for maybe 1 or 2 periods of a capture from a satellite, this would not be a good candidate for taking a median, because I'm basically whatever change occurred, I'd be smoothing it out over a broader time period. I'd be canceling that out. And so if I'm looking for something that is like has a very small time scale compared to my capture periods, right? I need to not use a geomedian, because it's only going to appear in a couple of my captures. And I'm going to really need to focus on filtering all this data to find those few captures instead of trying to do the thing. So where the Geomedian excels is over those multi-year time spans, if you're looking for kind of the more gradual, larger changes that occur, and you want to eliminate some of the noise that may be in your data set. Do you have any follow-ups? Any follow-up questions? Okay.
Bye. Bye.
I think we can do a follow-up with this product. So would anyone else have an extra question? As I can see, we are on the hour.
Yeah, no, I got to understand more about the Geomedian when he said that actually it's for noise cancellation when you have time series data set. And also when you are dealing with an occurrence or an event that is happening within a short period, it's not good to use it. I think that sums it up for me.
I think that's much more clear. Otherwise, Brian, you'll be able to share the links to these documents, the PDF, so that we can keep everybody informed. And also, we wish to pick some topics for next week's presentation from any one of you.
Yeah. Is there something somebody would like to hear more about?
I think maybe they'll be able to share via the other channels. Otherwise, mine is to thank you guys for your time. As you can see, I was joined by another space enthusiast. Looking forward to seeing everyone next week. Thank you very much for your participation. And bye-bye.
Bye-bye. Bye-bye.